Hello everyone, this is Muhammad Afifi from ConexTech. We are demoing today our latest version of TCP M-AT Adaptive Transmission, our cutting-edge congestion control algorithm version 1.4, which brings twice the improvement over the previous version. The Linux kernel we are using is 6.14.0, which is one of the latest kernels and has all the updates and upgrades to the TCP Cubic and Google BBR we are going to demo against. Let's start now with BBR. Okay, and then Cubic. Okay, so the connection started all at high rate, but at the beginning of the connection, at the initiation of the connection, the rate the connection starts at it doesn't have to be the rate that the connection will stay up to, because at the initiation of the connection, the congestion control algorithm component, which recalculate and calculate the speed of the internet connection, the TCP internet connection, has to check for congestion. So it adjusts the rate according to the network conditions, and as the network evolves, the rate is adjusted. So one of the things that makes the congestion control component reduces the rate of a connection is that it confuses congestion with poor signal, because poor signal brings higher delays and higher packet loss, which is the indicator for a congestion for many congestion control algorithms, unlike our technology, which differentiate between a congestion and a bad or a poor signal. So now the rate is our technology is 650 over 650, or about 650 kbyte per second, and already over 13% has been uploaded, while Google BBR is still, but it's saying 587.7 kbyte per second, but it will definitely decrease as it's whenever it's still like that, it means it's gonna decrease dramatically. And Cubic decreased to 26.7 kbyte per second, and 0.40% has been uploaded. The file size we are uploading is 438.9 megabyte per second, and the website we are using to upload the file and observe the speed of the file upload and the progress of the upload is called the filebin.net, which is a file sharing service we are using to observe the speed of the upload and the progress. Okay, so now our technology is over 640 kbyte per second, and about 25% has been uploaded, while Google BBR is still 587.7 kbyte per second, but only less than 0.5% been uploaded. And Cubic is reduced to 17.2 kbyte per second, and about 50.5% has been uploaded. Okay, so now Google BBR decreased to 13.9 kbyte per second. Let's recap on our conversation on previous videos. Now, Google BBR and Cubic pretty much they dominate the market for the TCP internet connections, as they both are general purpose congestion control algorithm, and they doesn't require modification to the client side, and they are only server side implementation as our technology. So they dominate the market. They dominate the market for TCP transmission control protocol on the internet. Now our technology rate is over 700 kbyte per second, and about 42% over 42% has been uploaded, while Google BBR is still crawling about 13.9 kbyte per second, and less than 1% has been uploaded. And Cubic is 15.3 kbyte per second, and also less than 1% has been uploaded. The file size I mentioned is 438.9 megabyte per second. So I would like to elaborate about the server side implementation only technology, which is one of the best advantages we have for our technology, is that it doesn't require modification to the client side or the infrastructure. Only a software, you have to install it on the server side, and you have all the system benefits immediately. All millions of customers around the world connected to one server, which, for example, Apple or Vodafone or Verizon or whatever the service is, you have to only implement it on the server, and all the clients using this service will get the benefits of the system immediately without software updates or modification to the hardware. So that's one of the best advantages of our technology, which is a server side only implementation. Now the rate, as we can see, is Google BBR and Cubic around 13.9 or 13.3. Now Google BBR reduced to 9.4 kbyte per second, and Google BBR is 0.75%, while Cubic is 1.08%, which is about 1%. So now we can say that it's more than 70 times improvement, or 7,000 improvement over Google BBR and Cubic. But we will see by the end of the video how far it can reach. Now, okay, so that's a screensaver. Let's continue. Now, why would our technology has this optimum rate while Google BBR and Cubic is crawling? Is that because the congestion, which is the congestion control algorithm that controls the congestion in a network, has the same indicator as the port signal. The port signal has packet loss, high packet loss, and longer delays or round trip times. So the congestion control algorithm, state of the art, like Cubic and Google BBR, they confuses the congestion with port signal, so they reduces the rate. But what actually happens is that the rate can be improved when the signal is poor, but when there is a congestion, the rate should be reduced. That's our technology. What it does, it increases the rate while there is poor signal, and reduces the rate when there is congestion, actual congestion. So it differentiates between a congestion and poor signal, which is a very bottleneck for state-of-the-art congestion control algorithm, that they can't differentiate between a congestion and a poor signal or bad link. Networks that can benefit from our technology is satellites, 5G, 4G, and future 6G. Let's recap. Our technology is about 800 kbyte per second, while Google BBR is 9.4 kbyte per second, and Cubic is 12 kbyte per second. Google BBR less than 1%, and Cubic is 1.32%. That's over 90 times improvement, or 9,000% improvement over Google BBR and Cubic. Thank you for watching.